Well, welcome. A warm welcome to our university and a warm welcome to the academic awards sessions. And this is the first session that we're going to have, the Bachelor of Science degree. These are the nominees. We're exceptionally proud of our nominees. It's really, if you think about it, we have about 1,700 graduations in the bachelor phase each year. So these are the best of the best of this year. And so I think that being nominated itself, I think, is an honor, because you've all been nominated within your own program. And based on the bachelor thesis that you've had and all the courses that you've taken, and taking that together, this is the nomination that we have. So we're exceptionally proud of our students. It's really amazing to see what they can do after, say, about 3 years in the bachelor phase. The enormous growth that they've witnessed. And I think you as parents and family may have seen that. There's quite a change between the first year student and the third or fourth year bachelor students that we have. So I hope you're proud of your kids as well. I've been through a ceremony like this with my kids, and I was exceptionally proud at that point in time. Just their graduation of them is really special. So I hope you will enjoy the day. This afternoon we are having MomenTUm, which is the big celebration where we have everyone together. And yeah, I'm looking forward to having you at that meeting. Also a welcome to the deans of the departments, to the supervisors. I see a number of supervisors and I really would like to thank you for all the support that you've provided to the candidates that we have over here, and obviously also to the jury. It's almost an impossible task to pick the winner, because you have all these wonderful theses, and then you have to pick a winner. I think it's almost impossible to do so. But nevertheless, they have done so. The procedure of today is pretty simple. Each of you has a short pitch, which was also on the website. I think you've seen it. We'll show it here again. Then you come forward, you get a certificate. And once we have a certificate, you come to me, and there's a cross here. And we'll stand on that cross, and there's a photo taken of that. And at the end, I will announce the winner. So on my last card is the name of the winner. So we have to wait for that for about 10 minutes or so.
It is time to rethink the health industry. We have to go from this short-term human-centered vision to a long-term vision that includes the health of our planet. Remask rethinks the health industry by proposing a circular product-service system of medical-grade face masks. It shows that it is possible to find solutions that are healthy for us and for our planet.
Please come forward and pick up your certificate. Yeah. If you come here, I won't shake hands, we will box. Is that okay? Yes. Yeah? Following the regulations, okay? Wonderful.
Supplier quality assessment is highly knowledge dependent. Experts have to manually assess supplied parts and investigate why system failures occur. Our research investigates the use of association rule mining in order to automate the thought process of experts when examining these failures. This drastically reduces the workload of the employees and enables them to actually focus on the cases that do require in-depth investigation. In doing so, our research has provided a foundation towards automating knowledge-intensive processes.
Thomas couldn't make it today. He's probably vacationing somewhere. I don't know what he's doing, but so we move to the next candidate.
Hello, my name is Pablo, and the importance of this thesis has to do with how necessary it is for our cities to grow and to improve, always reusing the existing structures. It is a moment to look back at all those abandoned sites that we might encounter in the city and think, what role can they play in the new city? And of course, this is a matter of sustainability in the built environment, but it is also an issue that has to do with what kind of memory do we leave for the next generation. Thank you very much.
Thank you. Congratulations. Yep. Thank you.
Time molecules can be found all over the world. You're probably wearing them right now in your clothes, have them on your rooftop, in your solar panels, or in your body through food coloring. One type of these dyes are the streptocyanides. Their crystals show a metallic-like reflection, except for some sharp minima in the spectrum. In my research, I used an optimized theory to predict this reflection in order to understand the origin of the phenomenon.
Yeah, congratulations. It still feels a bit off the box.
Imagine a future in which automated driving is a norm. In such a future, we would like our cars to be both safe and reliable. However, even automated cars will have many inaccuracies. Take, for example, measurement inaccuracies on GPS or deviations from sensor data. In this project, which has been conducted on ePUC setup, it is shown that observers can be used to deal with and overcome such problems by identifying the system dynamics and integrating the observer design.
Congratulations. Okay, yeah.
Can mathematics help to fight terrorism? Well, my research shows that it can. How? I model the interdiction of terror plots as a queuing model, and then I apply sophisticated methods to study it. This analysis can help to make strategic decisions. For example, how to deploy agents in order to prevent as much damage as possible. Sounds great, but can this be used in practice? Well, Edward Kaplan, who first researched terror queues, has successfully applied his findings to Israeli special forces, so this type of research clearly has a potential.
Congratulations. So this is a bit of walk of fame, right? Congratulations. Yeah, thank you.
Have you ever been frustrated as a presenter by your audience not looking at you? Well, maybe you shouldn't be. By investigating entrepreneurial pitches just as you see in the TV show Shark Tank, it became clear that your audience not looking at you, well, it might actually be a good thing. A big part of this is how you use gestures to convey information to your audience. And by helping to unravel these mysteries around conveying information in a presentation, my research hopefully aids entrepreneurs in convincing investors to let them build the future we all will live in.
Congratulations. Yeah.
Thickness maps of the cornea are a valuable tool for eye surgeons to monitor disease progression and patient recovery. As part of my bachelor thesis, I developed a machine learning-based image analysis tool that can accurately measure the thickness of the cornea and construct thickness maps specifically for irregularly shaped corneas due to surgery that proved to be challenging for currently available tools. This work has the potential to enhance the clinical workflow and ultimately improve patient care in the field of ophthalmology.
Congratulations. Yep.
Lightning. It has mesmerized us for millennia and helped us understand electricity. However, scientists are still not sure how lightning initiates in the first place. A popular theory is the hydrometeor theory, where ice and water particles enable lightning inception. For my study, I constructed a model to determine which hydrometeors are most likely to do so. A greater understanding of this phenomenon can help develop more accurate weather forecasting. And don't we just want to solve this mystery?
Congratulations.
Self-compassion is a relatively new concept and means that you are kind and forgiving towards yourself. Having high self-compassion can help people deal with negative emotions. To increase self-compassion, we extended an existing VR training so that it can be performed at home with a smartphone instead of in a VR lab. We tested the effectiveness compared to an established letter writing exercise for both men and women. Gender mattered. Letter writing worked best for women, while the VR training worked best for men. This study demonstrates for the first time that it's important to take gender into account when developing and testing self-compassion trainings.
Congratulations. A bit closer. Yeah.
In today's day and age, almost all solar panels are being produced in China, and they are being exported all around the world. Given that China was not one of the pioneering countries in this technology, this raised the question: how did China become such a dominant market player in such a relatively short time? During my research, I have tried to answer this question from the perspective of innovation and policy, and I found that China's plan-based policy approach was one of the main drivers behind China's accelerated trajectory. What this teaches us is that if the West would want to become less reliant on China for their solar energy, they should start with revisiting their own policy instruments regarding their domestic innovation in the energy sector.
Congratulations.
Over the last couple of years, machine learning has become more popular as it has shown its potential in solving tasks that are difficult to solve using other methods. In my thesis, I explored the possibilities of using machine learning and shape description to classify the mutation status of brain tumors. It is important to know the mutation status as it determines the needed treatment. Currently, the only way to determine the mutation status is through a biopsy, which is an invasive procedure. I believe that a future in which machine learning is used to avoid invasive biopsies is a future in which patients who already are in a difficult situation have one fewer difficult moment to go through.
Congratulations. Yeah, thank you. So how often did we hear machine learning today? Quite often, eh? It's something that is percolating throughout the university very rapidly. All this artificial intelligence technology that we have is gaining wide use within the engineering domain. I think you've seen some examples thereof today. If you see this young talent, exceptional talent, you can only have confidence in the future. Because we have so many challenges that we need to address: societal challenges, climate change, energy transition, healthcare. And we need talent for that. I'm looking at you. You can make a difference. So I have great confidence in young people, the young people that we educate at our university. But now I come to my last card, the second card I have, because that had the name on it of the winner of today's award. And it is on the Bachelor program. I'm looking at the Dean, Electrical Engineering, Sheer. Congratulations. So with it comes a prize and a certificate. And I suggest that we keep it up and have a picture of it. Is that okay? Yeah. Yeah, great. Maybe we can take a picture of all the nominees and have a joint picture, and I will wrap things up. Okay? If you come with me, you're the winner. And if you somehow can form a line at that side and this side, I think that will work out. It's almost like a military exercise, moving a little bit, and then. Yeah, great. It's your prize, not mine. Are we okay? Yes. Okay, wonderful. Well. Well, this basically is the end of this session. Again, congratulations to all of you. Never forget you were nominated by your own program, and you can be very proud of that. There can only be one winner, and the jury had to make a very difficult selection, but I think you deserve it very much. I hope you appreciate it, and I wish you a lot of success in the next steps that you're going to take in your program. I hope you're proud. I hope you enjoy the day. It's a special day, I think. MomenTUm, we celebrate the graduation of many. Some of you will have the MomenTUm tomorrow, depending on the program that you're in. So I hope to see you there again and enjoy the day together. Thank you. Goodbye. Oh, okay. If you want to have a drink, Senaatzaal, that's over there. That's there's in the Senaatzaal, there's drinks available, and you can have coffee or whatever and celebrate the moment. Okay? Thank you. Are we ready to go? We ready? Okay, good. She's the boss today, so that's why I'm asking that question. A very warm welcome to the university here today. A warm welcome also to this Master of Science Best Thesis Award session, the academic awards that we have. Warm welcome to family and friends, deans, supervisors, members of the jury. Very much appreciated that you're all here today to celebrate this special moment. The master phase, I think, is a special part of the program. And actually, when I think about my own studies, I found that to be the most fascinating part of my whole educational program. Because it's here where you really start to learn to push the boundaries of science and technology. And I remember that at that time I was gradually becoming part of a research group, and they were working on a new theory. And I had no idea what they were talking about. It was sort of like magic to me. And it took me quite a bit of an effort to really understand what was happening. But ultimately, I could make that little additional step that they were making. And I think many of you must have experienced something like that. So we're looking at the best of the best. So these are the best that we have at our university in the master phase. They've all been nominated by the programs. And I supervise many students, so I know if you're at this stage, and you're sitting here and you're the best of the best, that's really exceptional. So you can be proud of that. I hope that family and friends, you understand that this is a very special group of people, and we can have great confidence, I think, in them. The theses that were evaluated by the jury were all of exceptional scientific content, making the relationship with, quite often, with societal challenges, or making just a next step in science. And it's really amazing what young people can do in that sense. So we're very proud of you as well. And I hope that you're going to have a wonderful career in whichever direction that you're going to take. Today, what we do is a simple procedure. We will see the pictures of each individual. You may have seen it already on the website. If you want to, we will have the pitch again. You will come forward after the pitch is finished. You'll see your name. And then you can pick up the certificate. You will come here. There's a cross right here. And that's where we take a picture. And I'm not allowed to shake hands, so I will box with you. I hope you understand. Still say the formal rules that we have. I hope next year we can go back to the normal mode, but today is still a short box. And then after we've seen everyone, I have the privilege to announce the winner. It's on my second card. So I know the winner, obviously. And then at the end, we'll take a picture of all of us. And then there is drinks, so you can celebrate the event. And if you would like to see more of today, there are lots of things happening on campus. The Dutch Design Week is also starting. So I think there's lots of things that you can see on the campus today. So I hope you're going to enjoy it. And now we start with the first pitch.
Many of us had to change from working in an office to working from home due to the pandemic. In my research, I examined the interrelationship between mental health of office workers and their indoor environmental quality at home, which consisted out of temperature, sound, lighting, and air quality. With my findings, I hope more research will be done to our work environment, which eventually will lead to more optimized, balanced, and healthy workplaces in the future.
So today, this is the Walk of Fame, okay? Yeah? Congratulations. Yeah.
Here's the cross.
Yeah. Yeah, wonderful. Thank you.
Often, when researchers want to study a system, they start with a few trial and error experiments, followed by varying one factor at a time. This is not always efficient. We developed an alternative approach to experimentation. In our case, this allowed us to systematically design collagen gels tailored to specific tissue engineering, bioprinting, or drug delivery applications. This will help tissue engineers to grow organs in the lab. Hopefully, it will also inspire fellow experimentalists to make their research projects more efficient.
Congratulations. Yeah, wonderful.
If you want to live more sustainably, environmental footprint calculators aim to help you do so by informing you about your personal environmental impact. But these tools often fail to actually change people's behavior. So how could they be made more effective? Based on the results of my study, I came up with several suggestions for improvement. After graduation, I continued my research at TUE in collaboration with organizations like Milieu Centraal, contributing to the development of better footprint calculators and helping to help you make the future a little bit greener.
Congratulations. Yeah.
Have you noticed that in everyday life we are increasingly surrounded by materials that respond to their environment in smart ways? Think of your mobile phone screen that vibrates when you touch it. But it doesn't need to stop there. We can also envision drugs getting released into the blood flow on demand, and even solar cells can clean their own panels. To make this a reality, we have developed a theory that pinpoints how to most effectively design these materials.
Yeah. So I can challenge you and find a solution to that equation. Congratulations. Yeah.
The benefits of self-driving cars are undeniable, but their complete autonomy has not been fully reached. In addition, users still struggle to accept the technology. Then, how can we increase their autonomy and the acceptance from the users? My research aimed to use a novel approach by introducing emotions into autonomous cars. I designed safety situation awareness using emotional states, which can be communicated to the user. In this way, the self-driving car can make decisions based on these states and makes them transparent to the user. I also show that these states can be tailored depending on the user driving styles, making them driving more human-like but safer.
Congratulations.
Thank you.
Millions of people worldwide are affected by autoimmune diseases such as psoriasis and multiple sclerosis. During my graduation project, we explored a novel strategy to inhibit the nuclear receptor ROR-gamma T, a promising target for the treatment of these disorders. By targeting two binding sites of this protein simultaneously, we developed a highly potent and selective bitopic ROR-gamma T inhibitor, advancing our fundamental understanding of this drug target and contributing towards future autoimmune disease treatments.
Congratulations. Yeah.
Hi, my name is Danielle and I represent the Department of Industrial Design. The societal problems we are facing are getting more and more complex, and most of our approaches, our practices, do no longer suffice. That's why we need to design practices that correspond with the complexity and learn how to collaborate on doing so constructively. With my graduation project, I gave an impulse to this transition by designing an accelerator program for wicked problems. We implemented this concept both at the department and at SET, and are now researching in practice how these principles can enable us to deal with the complexity of societal challenges on the long run.
Congratulations.
Automation is the future. We are seeing multi-robot systems becoming increasingly important. Think, for example, about robot warehouses. Thus, it is vital to develop efficient algorithms that can plan collision-free paths. However, this motion planning problem is computationally very hard to solve. In my thesis, I proved that under certain assumptions, namely some spacing between the robots, there is guaranteed to be a solution, and I describe an algorithm that can find it efficiently.
Congratulations.
When operating on brain tumors, damaging white matter bundles, the information highways of the brain, can have significant consequences for the day-to-day functioning of patients. Locating these bundles in individuals has been a challenge for over 2 decades. But state-of-the-art methods are either not accurate enough or so slow that the results are not available before surgery. My algorithm speeds up a recent method, such that it can find large bundles much faster. This allows the new method to be used in a clinical setting, which greatly improves the surgeon's ability to avoid important bundles, and thus improves the expected quality of life for tumor patients in the future.
Congratulations.
The world around us is getting more and more complex, with reusable spacecraft, self-driving cars, and machines that can produce handheld supercomputers. At the same time, all these machines need to meet with increasing societal, environmental, and economical expectations. To overcome these challenges, engineers often struggle with complexity issues to design the control algorithms, the brains of these machines, which ensure reliable and high-performance operation. Based on my work, you can now use intuitive and easy-to-use design tools to create high-performance control algorithms, even for the complex engineering systems of tomorrow. Okay.
He's still very fond of the first-year course calculus. You can see it next to him. Congratulations.
Process mining supports organizations to better understand and thus improve their processes using data. For some processes, it's hard to turn data into information and information into insight. This applies to processes where people log what they have done in so-called log entries. My research has been the first to apply process mining to these types of log entries. This opens up the opportunity to better understand processes in a wide range of organizations, from business to governmental organizations and from healthcare to high-tech, helping more people to stop guessing and act on facts.
So you see a number of these students have taken 2 degrees at the same time, double degrees. It's really amazing. Congratulations.
Thank you.
Yeah.
In the Energy Technology and Fluid Dynamics group at Mechanical Engineering, we work on computational fluid dynamics for high-tech applications. In my project, I've collaborated with electrical engineering to contribute to the development of an advanced electric motor, which can, for example, be used in the automotive or the medical sectors. To aid in the thermal design of the motor, both experiments and computer simulations are used. These computer models are comparatively cheap to experiments and enable the user to easily test different variations. We therefore developed our own computer model, which enables us to predict the airflow and corresponding temperature distribution, showing that the heat transfer is heavily influenced by specific air circulation zones inside the motor. Accurate understanding of these zones enables us to improve the cooling and ultimately develop a new generation of more efficient, advanced motors.
Congratulations.
Thank you.
Yeah. Oh, sorry, photo. Yeah, sorry. Yeah. So essentially, you've seen sort of a pretty wide spectrum of things that we're doing within the university. And this is only a small fraction of it, because we have more than 650 professors at the university, and they all have their own little niche in the research that they do. And it really goes from left to right, up and down, and it's wonderful to see that. And it's also wonderful that you've basically been able to pick the subject that you apparently really liked yourself, and you could work on it for some time. So we now come to my second card. And my second card has the name of the winner, and I'm going to reveal that. And it's from one of the graduate programs, obviously. And it's Guido Kusters. Congratulations. There's a big certificate over there. And before I give you hand over the check that goes with it, I will read the excerpt of the jury report to give you some impression of what has happened. So the thesis was well structured, and both the topic and research are presented in a very accessible and compelling way. The jury values the winner's independent and creative work in a complex multidisciplinary domain, combining mathematics, physics, chemistry, and computational analysis. He was able to solve a challenging puzzle regarding the behavior of liquid crystal molecules. And they also think you really broke through an important bottleneck in this problem. That's a significant achievement. Congratulations again. I will give you the check. You can take it. It's not mine anymore. Okay, now I suggest that all the nominees join me, and we take a full picture of everyone. If you could perhaps line up there and there, and then the winner is in the middle. Like this?
Yes, perfect.
Good. Yeah, wonderful. Yeah. Perhaps to wrap up, there's also an audience award. You may have seen it on the website. It was just published and gone online earlier today. It's another session, because we basically have all these pitches on the website, and everyone could vote. Your family could vote, students could vote, and we have well over 4,000 votes on all these different topics. And the winner was Floor van Schie. And you can actually look at the thing that she created, because that's the windmill that you see just in front of this building. And it's another program, and I'll give her the check at the other program if you like. But having said that, thank you again for being here. Once again, thank you to the jury for making this selection, and because it's an almost impossible task. You have these, I don't know how many, wonderful theses, and then you have to pick out the best. But I think it's well deserved, and congratulations with everything, with just the fact being nominated, and with the prize that you've just won. And I can only wish you lots of success in the future, your future career, whichever way you go. I hope you stay as a PhD student, by the way, but that's something else. There are drinks in the Senaatzaal, and you can celebrate the event. Thank you. Go? Do we have a go? Yeah. Now we have to wait for the live view as well. You ready? Good. Well, welcome to this session that we have on the academic awards. We have like a number of sequential sessions, if you like, the bachelor degree, the master degree, and now the PDEng degree. PDEng program is a very special program that we have at the university. It really creates professional designers in engineering design. And it's highly rewarded in the industry, in particular in the region that we have. If we look at the 3 engineering universities that we have in the Netherlands, we have by far the largest program in PDEng. And they're really highly demanded almost, I would say, by the industry. Welcome, very much warm welcome to this meeting, family and friends. I guess you're very proud of the situation that you have here. I hope you're proud. We are proud of these students. Also welcome to the deans. I see a number of deans of the departments, members of the jury, supervisors. I think many people have been supervised, and I think it's really great that we celebrate this moment together. You have been selected out of all the individual PDEng programs that we have. So this is the best of the best that we have this year in each of these programs. So you can be exceptionally proud of just being nominated itself. I think that's the biggest honor. At the end of the day, we'll select the winner. I have it on my card, the second card I have, but I keep it with me for a while. We have a simple procedure today. We've organized a walk of fame for you. So if your pitch has ended, you can pick up the certificate. And there is a cross over here. I will stand next to it, you will stand next to me, and we take a picture. And once you all had your walk of fame, I will try to announce the winner. Okay? Now, let's start with the first pitch.
I did my PDEng final project at the Efteling.
My project was about one word: experience.
We built multiple forecasting models that gave us the ability to predict the waiting times for the attractions, number of transactions in the restaurants, and crowdedness in different areas of the park. The output of these models are used as an input for a neural network model that recommends a list of locations to a certain group of guests to visit. Guests can use Efteling's Lab app, input their preferences, and answer a few questions, and then get tailor-made advices throughout their visit in the park. We aim to use data science and machine learning to manage and distribute the crowd in the park. I hope our contribution can make this magical and wonderful place even more enjoyable for the guests.
Ik heb wel eens een uitspraak gehoord van iemand waar ik helemaal achter sta, dat iemand die zich gedwongen aanpast bij de geest van de tijd, die vermoordt zijn persoonlijkheid.
Okay. Congratulations. Yeah, sure. Yeah. I hope that your app is going to help me the next time I'm visiting the Efteling with my grandchildren. Please. I always have to wait in long lines. Congratulations. Hope it starts? No? Oh, yeah, I know. Yeah. Originally, we anticipated, Arash, that you would not be here. So that's why we have taken out the pitch of you. But the Walk of Fame is still there. It's all yours. Let's box to congratulate you. Congratulations. Yeah, it's Corona time, so I have to be a bit careful. Yeah, congratulations.
Imagine to predict the outcome of a medical procedure before performing it on the patient. With our planning tool, Angio Support, choosing the best treatment is simple.
Angio Support is an easy-to-use interface to simulate all possible treatments. It allows the clinician to predict the outcome of a stent or bypass to choose what is best for each patient. So, if you want unclear support to be used in your hospital, vote for us.
Okay, congratulations. So they really collaborated together, and that's why you both get a certificate. Yeah. So did I get it right? You were predicting the fractional flow reserve? They're not listening to me at all. So you were calculating the fractional flow reserve? Is that what you did in the program? The fractional flow reserve, is that what you calculated? Ah, okay, good. Please. Yeah, absolutely. Well, congratulations. Oh, you're can we do it? Congratulations. Please.
Imagine a prematurely born baby that needs to stay in a hospital incubator. By attaching a camera and by using the Philips Remote AI Streaming Platform, also called PRAISE, we are able to remotely connect the parents with their baby in real time. But it doesn't stop there. The real power of PRAISE is the ability to connect AI. We can, for example, connect a real-time post-detection algorithm that allows a doctor or researcher to analyze the baby's movement patterns. This is just one of the use cases enabled by PRAISE, because in fact, PRAISE is a platform that connects humans and AI anywhere in the world over real-time audio, video, and data streams, enabling many valuable and potentially life-saving use cases that weren't possible before.
Congratulations.
Climate change is going on around us across the world. The industrial sector is responsible for around 30% of the global greenhouse gas emissions, and it requires radical changes in order to meet the 2050 climate goals. Industrial heat pump technology is an electrification technology which can replace a large share of the fossil-fueled industrial process heating, which leads to both energy efficiency and emission reductions. In my PDEng project, I considered high-temperature heat pump integration into two industrial sectors. They are the food industry sector and the paper industry sector, which consume significant amounts of high-temperature process heat in their drying processes. The results showed that integrating heat pump systems into existing installations lead to even more inefficiencies. Therefore, it is necessary to optimize the processes first prior to integrating a heat pump system. Despite the challenges, I am convinced that heat pumps can help accelerate the energy transition. I hope you are convinced too.
Congratulations.
We can't ignore it. We are all surrounded by smart and connected devices. And all these devices contain chips. New devices need to be faster and better. And that means that the chip inside needs to improve as well. And therefore, new types of chips are developed. I worked on a simulation method that ASML uses to monitor the manufacturing process for these new types of chips. Within this method, an algorithm was not working, and I improved it such that it does work for these new types of chips. My name is Loes van Rijswijk, and thank you for listening.
Congratulations.
Wow, artificial intelligence is really promising within healthcare. But an essential component of developing AI algorithms is having access to high-quality datasets. Hospitals have a lot of data stored within different applications from different vendors. Collecting this data and making it suitable for AI development is therefore not obvious. My design facilitates in the collection of large, high-quality data sets consisting of medical images and combined with other clinical information ready to be used for AI development. So now it's the time to unlock the potential of medical data.
Congratulations.
Festivals. Iedereen is er wel eens geweest. Maar hoe komen ze nou aan de grote hoeveelheden energie die ze verbruiken? Achter de schermen staan grote rijen dieselgeneratoren die enorm vervuilend zijn. Het JAM-project richt zich op de ontwikkeling van een duurzaam alternatief voor dieselgeneratoren. De toren gebruikt een combinatie van verschillende duurzame energiebronnen, zon en wind. Deze bronnen zijn gecombineerd met een batterijsysteem om festivals te voorzien van duurzame energie met elk weertype. De toren wekt niet alleen duurzame energie op, maar creëert ook bewustwording onder festivalbezoekers en organisatoren. De JAM-toren is gebouwd in 2019 en getest op diverse locaties door Europa.
Congratulations. Yeah. So now it's really my pleasure to announce the winner of today's award. The topic had to do with medical engineering. You've seen the work that was done in the hospital. We had 2 nominees on this project. But the jury could only select 1. That's unfortunate. So they had an impossible task, essentially. So they had to use a criterion, okay, which of the 2, because you've seen there are 2 nominations on one project, you collaborated in that project very intensely. So they had to decide, like Sophie's choice, and they used the thesis, because each of them had to submit independently a thesis to defend, and then they had to pick the winner, and so the 2 of you are sort of heating up, I guess, right now, because there they are sitting, and they selected Tim. Congratulations. There's a big certificate as a winner. You can pick it up over there. So let me give you an excerpt of the jury report. They were looking at the fractional flow reserve. The fractional flow reserve is used as a number to see whether or not you have a coronary graft that is blocked, essentially. And so it's a very interesting topic that is developed. The fractional flow reserve concept itself was developed by Nico Pels. You probably know him. He's a cardiologist in the Catherine Hospital and has been a part-time professor at our university for quite a while. So they feel that you have tackled a very real challenge, which is in a very multidisciplinary field with excellent social and technical impact at the Catherine Hospital. So with the tools that you've developed, you can really support the decision-making process of clinicians. And it's a wonderful step that you have taken. I hope I can avoid using it, but you never know when you get older. Yeah, sure.
Can I just add that this project was completely joined together?
Yeah, I hope.
Joint project and a joint prize.
Yeah. Yeah, it's the jury had to make a decision, but I think you can be very proud of the fact that the project itself was selected. I now have a prize that goes with it. Oh, whoa. There are 2. No. I have to take the first one. That's for the PDEng thesis. And it's easy to divide it.
Absolutely.
Okay. Great, wonderful. So if you may have seen, there's another prize that I can award today, because we also have the Audience Award. So all these pictures that you've seen of the Bachelor, Master, and so forth were also published on the internet, so everyone can have a look at it. And we asked everyone to vote on that as well. And we have well over 4,000 votes. So many people actually have looked at your pictures, which I think in itself is already wonderful. And there's one winner. And it was already announced earlier on the internet today. You may have seen it, Florensky. Congratulations. If you really want to see what she has created, just walk outside. Yes. Because it's functional at the campus, and it's there for the Dutch Design Week.
And also during Glow, so it will stay there for at least 5 more weeks.
Yeah. Wonderful. I have a certificate for you. And a prize, a check. You may have seen it already, but it's yours. Okay. So it's, I'm always excited to do this, because it's really a wonderful, exceptional talent that we have within the community. Out of, I don't know, you have 250 PDEng candidates within the university. And being the best of the best, I think, is special. So you can be really proud of what you have achieved today. And getting an award like that, and getting the Audience Award, I think, makes it even more special. I hope you enjoy it. There's a whole event today. Later on, we have MomenTUm, if you like. But there's also Dutch Design Week on campus. So there's lots of things to be seen. I hope you'll enjoy it. And if you haven't partied yesterday evening, there is another party tomorrow evening with Typhoon. What's the name? I forget the name. Typhoon. So it's free, but you need to register. For now, I hope you celebrate the moment, and there are drinks in the Senaatzaal. Thank you for being here. Did I pick? Oh yeah, the lineup. So one of the winners here, and the other 2 here, and then we just form a line. Is that okay? You have to be here. Center stage. Enjoy the moment. Hold it together. We moeten een beetje deze kant op. Okay. It's like a military sort of operation.
Perfect. Everybody happy?
Okay, great. Well, thank you. Yeah, you're free. I mean, the exit is over there, and then there's there drinks, and I don't know what else. Are we live? Good. Welcome. Welcome to this special meeting. Welcome also to family and friends if you're there. Supervisors, I think, and deans, and perhaps also members of the jury that had to make the ultimate selection of who will be the winner. I think this is a very special situation that we have, because in the PDEng, in the PhD phase, sorry, we just had a PDEng meeting. In the PhD phase, we really try to push the borders of science. Really might like to make a step in science. And it's fascinating. I think many of us, those who are professors, that's one of the things that really drives us next to education. Try to see if we can push the borders of science, and PhD candidates are very instrumental in that. So we try to educate in such a way that you can continue to push these boundaries and make a significant step. And it's absolutely fascinating to see what you can do. And we're looking at the best of the best. We have quite a few graduates each year, about 250, close to 300, I think, today. And then being selected itself should be a great honor to you. And we are very, very proud of you. You've been with us for at least 4 years, sometimes a bit more. And, well, and you have delivered wonderful theses. Because the jury was really impressed by the quality of it. Very high scientific quality, well-structured thesis, so they're also accessible. Sometimes you have something and you read it and you think, okay, what's it about? So being able to present it in such a way that others understand it as well, that's an accomplishment in itself. And so I really would like to congratulate you with that, each of you. Ultimately, there's only one winner. I hope you understand that. But I really hope that you consider yourself privileged by being in the position that you have today. I also would like to really like to thank the supervisors because they are very important in this whole process. There's very often a very good connection between a PhD candidate and the supervising team. It's really can operate as a team, and you can do wonderful things. Now, the way we do it today, we're having pictures of each of you. Not this one, it's just an old picture of mine. But we're having pictures of each of you. And then after the pitch, you will see a still image. And then there is the walk of fame for you. 10 seconds of fame walking to the certificate. And then we meet each other again here. That's the cross, and there will be a picture made of the two, of you and me. And then you sit back. And then after all of you have been here, I will announce the winner. And it's on my second, third card. Okay? Good. We start with the pictures.
The future of mobility lies in self-driving cars. But as a pedestrian or a cyclist, how do I know what a self-driving car is about to do? Has it seen me? Will it stop for me? It is important not to compromise safety. In my research, I have looked into how pedestrians can safely interact with self-driving cars. I'm happy to report that my results have led to concrete steps in the development of new communication interfaces. This will allow pedestrians to safely interact with self-driving cars and lead to safer roads. My name is Debargo Day, and I'll be very grateful for your vote. Thank you very much.
Congratulations. I have to box because of Corona. I hope you understand that, yeah? Yeah, wonderful.
Hello, my name is Camila Gomez, and during my PhD, I studied ultra-fast cooling of hot steel plates using the setup behind me and in collaboration with Tata Steel. This project combined an academic and an industrial side. From the academic side, we looked into the boiling regimes occurring during quenching using high-speed imaging to understand phenomena like, for example, rewetting. In the industrial side, we generated heat transfer estimations that can be fed directly into the process control systems in the real plant. The results of this project help open the way to a more green and efficient way to produce steel. Thank you for your vote.
Congratulations. Yeah, wonderful.
For a comfortable indoor environment, the lighting needs to be on point. In other words, we need human-centric lighting. My name is Thijs Keuselring, and in my research we made the first but essential steps towards human-centric lighting. We developed a holistic measurement device using high dynamic range imaging. Based on the information gathered with this system, we can, in contrast to existing systems, control the light appropriately in an autonomous fashion. Ultimately, we aim to achieve the level of daylight, which we typically prefer.
Okay. Congratulations.
Thank you.
Much like the hands of a clock, which always move in a clockwise fashion, magnets too can be chiral. On an almost atomic length scale, the direction of the North Pole can rotate and twist. And these chiral magnets can be exploited in new memory devices called racetrack memory, where chiral bits are raced across a track, or for a new type of computing, where we use waves and magnets rather than electric charges. In this thesis, we explored these chiral objects as well as waves and magnets to further enhance our understanding of chiral magnetism.
Congratulations.
Thank you.
Real-world data from different domains can be cast into graphs. For example, we have road networks and social networks. Given the graph, we always have two different views to explore it, the global view and the local view. In my study, I make contributions to mine the global and local structures of graphs. I study the global road discovery and the local community detection in both static and dynamic graphs. The findings can be beneficial for theoretical domains as well as applications.
Well, unfortunately, Yolong could not make it, and so Xiao Zhang will receive the certificate. Yeah, please come forward. We will take a picture of you, or you can make an envis. Yeah, no. We take a picture of you. You can send it to him. Yeah, good.
Imagine if man-made materials would be able to adapt to the environment, in much in the same way the sunflowers can follow the sun. Now imagine the potential of these materials in fields of smart textiles, medicine, and robotics. Imagine, for example, clothes that would become denser as you step outside into the cold, or micro-robots able to navigate and deliver drugs in your body when needed. I'm Marina, and during my PhD, we've brought such imagination a little bit closer to reality. So by developing polymers that can respond to light, we've shown the potential of these materials to remove wires or electrical circuits from devices. The developments made have opened new doors in the field of robotics and have allowed us to keep on imagining a more adaptive and smart future for the materials around us.
Congratulations.
Thank you.
Have you ever tried to change your bad habits but failed? Have you even used these digital technologies to help but were eventually disappointed? You are not alone. Many people find changing lifestyle behaviors extremely difficult, and as a consequence, unhealthy and unsustainable lifestyles can cause our society big problems. In my PhD thesis, I have shown the promises of combining psychological theory, computational modeling, and data-driven methods to make digital intervention systems more capable of supporting our behavior change.
So this time it's real. But you have 2 pictures, that's wonderful. Congratulations, please. Yeah.
Hello, my name is Shibing. I am a PhD from Electrical Engineering Department. My PhD research aims to create ultra-high capacity in-home wireless communication for 5G and 6G. We use integrated photonic chips as a means to achieve millimeter wave and optical wireless communication. Currently, we have implemented above 100 gigabit per second data rate. Hopefully, in the near future, everybody can enjoy our super speed. So, if you like our research, please vote me.
Congratulations. Yeah. So now I have the honor and privilege to announce the winner. It's about dancing. They're materials that if you shine light on them, they start to dance. You've created a robot. There's a beautiful picture or movie that I know of that is basically a robotics thing, and you shine light and it starts to walk, basically. And it's really fascinating that you're able to create materials that start moving because of the fact that you have light in it. So, please come forward. Marina. There's a bigger. So let me read you what the jury has said of it. You might enjoy it. The winner was able to combine impact of the work, both scientifically and societally, in an exceptional and well-balanced manner. She has developed innovative light-driven soft robotics, as you explained in the pitch, using fundamental research on advanced polymer materials, used both as actuators and as light-responsible materials. They dance. I have a prize for you, obviously, that goes with it. And I hope you have something nice to do with it. Yeah? Congratulations. Yeah, wonderful. Yeah? Really, there's only one winner, and that's a very difficult thing to do also as a jury. But I hope you consider yourself winners, because you've been nominated, each of you within your program, and you can be really, really proud of that nomination. I now suggest that we have a lineup, that we take a picture of all of you, and then I will wrap up the meeting. Okay? Please, come forward. Yeah, sure, absolutely. No, yeah, you can take both. Yes, you can take both. The winner should be next to me. Yeah, the big one. Oh, and the prize. Yeah, I will pick up the prize for you. Yeah, there are too many of these for you. Okay, wonderful. So, congratulations again. I hope you enjoyed the meeting. I hope you also enjoyed the day. There's another big event this afternoon, MomenTUm. But for those of you who do not have access to it, enjoy Dutch Design Week. And if you haven't booked a ticket for tomorrow evening with Typhoon, there's still tickets available. It's a big party, also the same location. Having said all that, once again, thank you very much for being here and enjoy the day. There are drinks in the Senaatzaal at that side. You're more than welcome to have drinks and celebrate the moment. Okay, thank you very much.